Welcome to the lecture series of artificial intelligence. In today's lecture, we'll see about Minimax search, and this is Shweta, working as an assistant professor in the Department of Computer Science Engineering at RMD Engineering College, and we'll start the lecture. So first, what is Minimax search? And Minimax search is something like it's an algorithm. It's a recursive or backtracking algorithm which is used in decision making in game theory. Yes, it will provides an optimal move for the player, assuming that opponent is also playing optimally. Yes. Minimax algorithm uses a recursion to search through the game tree, and is mostly used for the game playing in AI such as chess, tic-tac-toe, and various two players games are there. Okay. This algorithm computes the minimax decision for the current state. In this, two players play the game. One is called max and other one is called min. Okay, maximizer and minimizer, max and min. Both the players fight it as the opponent player gets the minimum benefit while they get the maximum benefit. Yes, uh, both players of the game or opponent of each other, where max will select the maximized value and min will select the minimized value. The minimax algorithm performs as a depth first search algorithm for the exploration of the complete game tree, and minimax algorithm proceed all the way down to the terminal node of the tree and then backtrack the tree as the recursion. So yes, next we'll move on to the problem. So the tree the given here is A, B, C, D, E and F, G. It will consist of these nodes, and where we are having the values for the node is called the terminal node, and the values is called as the terminal values. Okay. So it will start from the maximum and minimum, maximum, minimum, maximum, minimum. It will goes like, and if you have values somewhere means it is the terminal node. Okay. So what we are going to do is, first it's a bottom up approach. First what we are going to do is we are going to compare the values and we are going to get the maximum values from that to the next up node. Okay. So here we are having the H and I, right? So H and I, it depends on the D. So here we have to calculate only the maximum value. Okay. So minus 1 and 4 is the value. The what is the maximum value here? 4 is the maximum value. So what we are going to do here? We are going to update the maximum value here. We have updated it as at 4. So next is E. E here is it's associated with J and K. J has the value of 2, K has the value of 6. So what is the maximum value? 6 is the maximum value. We are going to update the E as 6. Likewise for F. F has L and M. L has the value of minus 3 and minus 5. So minus 3 is the maximum value. Update the minus 3 for F. And here G. G has N and O. 0 and 7. 7 is the maximum value. And then update the value of 7 to G. Okay. Next, the turn for the minimum. That is the turn for the minimizer. Minimizer means next we will get into the next step. Next step means B. B is associated with D and E. What is the value of D? D is 4 and E is 6. Here we have to get the minimum value. Minimum value is 4, right? So update the value as 4 for B, and here C. C has the F and G. F has the minimum value of minus 3 and G has the value of 7. What, which is the minimum value? Minus 3 is the minimum value, right? So update C as minus 3. Okay. So getting into the next step. In next step, it's the turn of the maximizer. We have to update the maximum value. So that is our top node. We are going to update the value, right? So next is 4 and minus 3. It has the B has the value of 4 and C has the value of minus 3. So it's turn for the maximizer, right? So we have to update only the maximum value. Which is the maximum value? 4 is the maximum value, right? So we are going to update the maximum value as 4 in the top node, that is A. So this is the complete workflow of the minimax of 2-player game. Okay, thank you.